All right. Hi. Welcome to this talk on extending the editor. I know Ari is presenting next door with an actual guitar ready to drive slides, so it's very nice seeing how this is a full room. I hope I'm worth your time. So what is this talk about? We're going to be talking about how to extend the editor, creating tools and utilities using what the engine already offers to add in terms of frameworks. Why do we want to do this? Well, this is going to avoid having to do any changes to the engine. That means our code is going to be easy to move to another project. It's going to be quicker to iterate because we don't have to rebuild the engine every time something changes, and it's going to be easier to maintain in general. We're looking to increase productivity. Not having to write boilerplate is going to help us getting started quicker, but also we're looking to simplify tasks as a result, either for ourselves or for another user. And we also want to make sure that we spot problems before they actually become one. Also, going through this approach is going to mean our tools are going to be easy to discover to a user that is already familiarized with the engine. They're going to be more intuitive to use because they're going to be in line with everything else, and it's going to be integrated with other parts of the engine. Also, these frameworks are heavily used in the engine, so you have a lot of reference points when you're implementing your own system. So how are we going to cover this topic? We're going to start with some entry-level frameworks, and the idea is that if you are new either to Unreal or to programming, this is a great place to start. This is a way to consolidate some of the patterns that you will need later on. And then we will talk about some more involved samples. These are not particularly complicated, but I'm assuming that you have some basic understanding of the framework of the engine. So if you're watching from home, just feel free to jump to whatever topic you're looking for. I built a project just for this. The samples are based on things I have experienced in the real world, but I wanted to make sure that there was something that you could download. So at the end of the presentation, you will see a QR code. There's a link to the presentation, and in a few days, week, I will also supply the project with the samples we are seeing here. And also towards the end, you will see a lot of references to classes that use these frameworks in the engine, and a few links on things that I wasn't able to cover in this presentation. So just a bit about myself. I'm Angel. I work for Tanglewood Games as a lead programmer. We're a studio in the UK, and we are mostly engineers that we provide support to other studios and their games. And my last project was helping out on the port for Grounded to Switch. So we'll start with scripted actions, which a lot of these things we can do with editor utility widget, and there's no problem doing that. This is a different approach that helps if you are not particularly averse in UI, and it's also a good entry point to more involved systems such as scripted tools. So these are actions that are presented to the user only when they are applicable. So here we are right-clicking on some actors, and we can see how random rotation is an option there. It's just a quick way to add a variation. We can do that also on assets. So here we are just applying very simple naming conventions to our textures. And the idea is that if something is not available to use, it shouldn't even be presented to the user. The way we create these actions are by inheriting from from utility blueprints. This is a very important step because if we use a regular blueprint, it's not going to register. So we select this utility blueprint, and then we can either inherit from actors or from assets, depending on what we want to do. Then we need to specify which classes these rules apply to. This is something that has changed in 5.2, I think. So you will see like a function doing this instead, if you look at some more examples. But because of this, we usually have a series of blueprints that serve as a collection for a certain type. So here, we're going to create any functions that we need. It's important that they have code editor set to true. If for any, this should be the case by default, but if for any reason your actions are not working, it's worth having a look at this. So what we are doing here is very simple. For anything we have selected, we check again if it's a texture, because if you have multiple types of objects, this action is going to try to apply to all of them. We check if it starts by t underscore, and if it doesn't, we just rename the asset and add that. This is a very simple example, but of course, this is something that you can expand a bit and be quite granular about these things. Then this is the other example with the actors, and something really useful about this is that anything that you expose as a parameter in your function is going to be presented to the user as a pop-up. So this is where, if you were to implement this from scratch, like using a widget, you will also have to implement this panel and so on. So this is something quite neat. The next framework is data validation, which is basically a great way to make sure that whatever rules you have in your projects are actually enforced. For that reason, I think it's a great entry point for tech artists. They're usually the ones who set the requirements for things like texture and meshes, and this is a way for them to break into tools and coding in a way that is kind of within the realm. And then, because this is something that we can start in blueprints, but then transition to C++, is a great way for them to do so. So here we have two textures. One has the naming convention right, the other one doesn't. And you can see that when we try to save, we fail, and we send a very loud message to the user. So it's very hard to miss. The way we can run validation is either through editor validators that we can extend using Blueprint, C++, or Python. This is something that we usually use for native classes in the engine, like a texture. Or if we have any custom objects or an actor, we can always override is data valid in C++ and do something specific for a use case. And validation is actually run every time we save something by default. Or we can also click on validate assets and any dependencies, or we can run it through the command line, but that will only evaluate those created in C++. So starting with the blueprint case, we also use the utility blueprint as a base, and we select validator base as a class. From there, first we need to override a can validate asset, which is a way to ask if this rule even applies. In this sample, we are checking if it's a texture and if it's in the project folder. That way, we don't have to evaluate things like plugins or things we got for the marketplace that is not really part of the project. And then this validate loaded asset is the actual rule that we're going to apply. Where we have different possible outcomes. If this doesn't apply in the first place, we can return not validated. if this follows the naming convention, where we're gonna say it passes unwritten valid, and if it fails, we actually send a message to the user saying why we failed. This is something very very important. We have the option to also send a warning even if we pass, but it's usually a good idea to be a bit more black and white with your rules. Let's see how how the other option is implemented. And this is a very simple example, but this is based on a real problem I saw in a project. Someone created a very versatile system where you have like a patrolling NPC that could reference any actor as a waypoint. And we noticed how every 8 minutes into the game, we would crash. And the reason is because we had an empty pointer that we were not checking for. And of course, as a programmer, you should always check that this is valid, but there's no graceful way to handle this since this is a design problem. So the idea here is to tell the user early on that this is not something we expect, that this should be either a valid point or it should be removed. So this is a component handling that logic. It was running on the tick. We can override this is data valid as long as we are in the editor. We need to wrap it in with editor because when we compile, this won't be a part of the game. And the first thing we do is we call a super because there's a chance we fail for multiple reasons. So this is the way we chain our results. We want to run this check on every point of the hierarchy, and if we find an issue, if one of those points is not valid, we just append like the reason and return invalid. So if we fail because 2 points are not valid, we're going to send 2 messages to the user with point 3 and 5. And this is how it looks. The moment we remove that reference and try to save the actor, this is going to complain and tell the user why. So we are catching this potential issue before they even submit those changes. And from now on, when we move to full C++ territory, and this is a very simple framework that I think is very underused. Every time you see this notification popping up on the corner of your editor, that's a notification from Slate, and this is basically a one-liner. I think that sometimes we have the assumption that people will always have the output log open, and that's not always the case. So if you have something to say, this is a way to make sure that the message gets across. And I think that giving confirmation is as important as communicating problems. I think that when you have a tool that is pleasant to use, that you get positive feedback when it works, it's a way to make it even easier to use. So here, when we are renaming, and when we are applying that naming convention from before, we are seeing how we can actually tell the user, well, this is how many things I've changed for you, and in this case, we've added a link to the documentation if they want to understand why it changed. So just because I wanted to connect it to the other system, here we're implementing a function in a Blueprint library, and the first thing we do is we build a struct for the actual information of what we want to notify. We need to pass like the text of the actual notification as the main parameter, and then we can override a lot of different things. This is very versatile. We can have buttons, we can have loading bars. Here, I'm just changing how long it's going to be on the screen. I'm grabbing an icon from the engine, and if we supply a hyperlink, we just at that link that you can click. Then it's a matter of just grabbing this manager and using that abstract to build the actual pop-up. This was something dependent on the editor. It's not anymore, so it's very easy and safe to use everywhere. I'll still wrap it in with the editor because we don't want this information in the game anyway. And then it's a matter of just wiring this to the example that we saw before. If we rename something, we just count it and then tell the user what changed. The next example is how to customize digital panels, and the power of this is that this can be something we associate with engine classes. This can serve as a wrapper where we either make things easier for the user, or we even hide stuff that is not relevant in our projects. Say you don't want to allow a certain system to be dynamic. You want something to have mobility set to static all the time. So don't even show it to the user. That's not an option. Here we are hard coding like the range of our directional light between 0 and 10, and we are giving the user a way to drive that through a slider rather than typing values that might be out of range. So the first thing we need to do is to create an editor module, because this is not something we want in the game. It's a very common practice to have it in a plugin, so it's even easier to port, and we have to make sure that this is something we call after the engine is already initialized. Then we can create our own class from digital customization, and we override customized details to actually do something with it. That detail layout is going to give us access to the objects that we're actually editing. So we are saving them so we can use them outside of the function. We can hide any categories that we don't consider relevant. And here we are adding a new category and setting it to the top of the list. From there, you can just use any slate to add some extra elements. Here, it is a very basic slider that is bound to our custom function, where we actually get any lights that we have selected and set the value from the slider. Simple as that. The last step is to register this new layout with the class, whether we are overriding, and we do that when we start this editor module. And again, this is something that there's a lot of samples in the engine, so it's not something that you have to memorize or to write from scratch. I think that's the power of having so much material that we can use, is that if this is something new to you, it's easier to modify and copy and start like developing an awareness of this area of the engine rather than having to write it from scratch. Then this is one of my favorite frameworks. Component visualizers are a way to display some visual information about anything that we have selected. This is used a lot in the engine. This is how splines are dealt with. And again, this is the same example of this patrolling agent. If we select it, we can clearly see where the route is, if we have any obstacles, and despite the name, we can actually modify and interact with this visualization. So here we can see how when we move these points, we're actually moving the actor that component is referencing. So this is a way smoother experience compared to selecting an actor and moving it and losing track of what you're actually modifying. Like we did before, we want to make sure that the visualization is part of an editor module, but the component itself, because in this case is handling the logic of the patrolling, it's going to be in a runtime module so that it can be part of the game. And this is something that we see everywhere, this double structure of the editor and runtime modules working together. So obviously, with the one in the editor, it references with the one that goes into the game, and it has any references to the frameworks in the editor that are gonna be removed when we build the game. So in this case, we are extending from component visualizer, and we have two main options for drawing any info. The first one is going to be based on the 3D space, on the world, and we use this PDI as a helper to draw things there. And if we want to do things in 2D, like drawing text, we have to use the one where we reference the HUD. So it's all screen space, and we use a canvas instead. So let's see an example of both. The first one, well, this is what gives us access to all the functionality. We're gonna store the components that we are dealing with, so we can use it in other places. And then for each of our points, we can just draw like the actual point and align to the previous point. There's a lot of functionality here where we can draw a lot of shapes. We can even draw 3D meshes, and this is how the gizmos in the editor are drawn. Then, if we want to draw some text, this is less common, but all we are doing here is projecting 3D to the screen space. We have to change the origin a tiny bit, but then it's a matter of calling this draw item in the canvas for the text, for the ID of the point that we are modifying. And again, when we initialize a module, we have to make sure that we link this visualization with the class that we are modifying. As we said, the really powerful side of this is how we can actually control and modify that information through interaction. And for that, we use base proxies. We can use the base class, but it's very common for us to need to store some information on that proxy. Here, we want to make sure which point in the route we are selecting. So we are adding that ID here. We use this macro to help us with some of the magic that happens in the background, and then we add that again to the C++, to the CPP file, so that Unreal can do these things. So the way we declare a proxy is by wrapping any elements that we are drawing and saying this is something that I want to make clickable. So we have to create a new proxy from the type we just created before we start drawing, and whenever we finish, we just set that proxy to null. And then it's a matter of overriding whatever functionality we want. Here, we need to override what happens when we click, so we can track which point we are selecting. We want to override where the gizmo is going to be displayed, and then what happens when we move it. So yeah, here we basically grab the ID from whatever point this proxy is representing. Then we can access it to get the location of the actual actor that we are linked with. And whenever we move that gizmo, we just read how much we've moved and then set that location for the actor. There's a lot of things we can do here. There are contextual menus, there are shortcuts, and as I said, it's very used in the engine. So I think the spline component is the best thing to look into if you want to take this further. Then this is actually the final framework, but we have split it in two. The first half is basically how to create or how to associate any custom classes with the editor in a way that is treated like something native. And this is, again, a framework that has changed in 5.2. I'm going to be covering the new system, which makes things a bit simpler, like especially when it comes to creating categories. Here it just ran real fast, and but the old system is working in the engine. Just be aware that if you search any info on this, you will probably see the old system, which is going to be removed at some point. So we know the drill. By now, we have the object that we're gonna use in the game in a runtime module, and then we have the factory, which is editor only in the editor 1. We're gonna create our own factory from uFactory, and we need to tell which class we're gonna support. We can also specify whether we want to support a creation, import, and editing. An example of where we wouldn't want some of this is a texture. It doesn't make sense creating a texture from scratch, so we don't support create new, but we do support import. In this case, is the other way around. And then in factory create new is when we actually handle the creation of this object. Then we use you as a definition default to customize how this is actually presented in the editor. And first we have to specify again which class we are supporting, and then it's a matter of just changing name, color, icons, and in this case the category. And this is the biggest change. In the old framework, there was a hard limit on how many categories we could have. We didn't have subcategories, so this really simplified the process. And then this is also going to give us a great entry point for creating a more involved editors. This is just an extension of that class, and the first time we used this was for a series of styles that we would associate with Houdini assets. This is a great way to make sure that your systems are properly modular. Here we basically have that same editor when you double click something, but we have a world that we can use within the tool. We can take it's very useful for displaying things that are frame dependent, like tools around characters and animations and so on. And as I said, like this forces really good practices, because then when we place it in the world, we know this is already going to work. So we're going to be extending the module that we created in part 6, but we are going to add an asset editor toolkit. And the value of this is that toolkits are everywhere, like the more you work with these frameworks, the easy then it is to go to similar frameworks. So whenever you are adding any menu extensions, this is a very common pattern, and you will see how a lot of things translate. There's a few things that we can override. We are using a pattern that you see in a lot of tools where we call this custom function initialize that will assemble everything. So let's see how that looks like. First, we're gonna break down what the anatomy of this tool is. We basically have 3 areas. In red, we can see a viewport. In blue, we can see a details panel, which is the default thing that we see if we don't change anything. And then we have created like a placeholder so that we can better understand how we can split things. In this initialize function, we're gonna save again anything that we are editing, so we can reference it in other places. And even though this looks a bit daunting if you haven't used late, all we are doing here is we are defining the shape of this tool. We are not adding any content just yet. We are basically defining areas and referencing those by name. So for that we use the layout, and we are just adding 3 tabs based on these names. So you can see how there's a very clear relationship between one and the other. And finally, we just call this internal function where we pass the layout and the object whenever this is actually opened. And then in the other function that we were overriding, the register tab, this is when we actually add content to those areas. So we use the tab manager for that, and we basically register every individual tab. It's just a doc tab, but that means it's something we can move around and change the layout, and we just add some slate components to those slots. Then here is the same pattern. It's a doc, an overlay, and just some text. And ironically, the one that comes by default is a bit more involved. We are grabbing a module that gives us access to that details panel, set the object we are editing, and just add it to the slots. The final thing is to wire all of this back to the definition asset that we used in the previous framework, where for everything we open, we have to create that toolkit and initialize it. With the actual viewport, we are first using slate arguments as a way to support sending a reference to the object. We need to override these functions, and then is the construct and make viewport where we handle the actual creation of the scene. Here we're gonna create a preview scene before we even construct it, because otherwise this system is going to grab the viewport that we already have open, which is the one in the game. We grab the preset or the custom objects from the arguments that we created before, and then it's a matter of just treating this very similar to begin play. And this is when I'm saying this forces you to have like clean and simple patterns. Here we are just creating that building, sending the preset, and it's the building itself that is bound to any events when we change the values in a preset. Then we have to create the actual preview scene. there are 2 versions in the engine. One is older with simple lights, and this is the one that we use, for example, when we edit any meshes. And then we can set like the place for our camera and so on. As I said, like this is not a comprehensive list of frameworks, but I'm hoping we're starting to see very similar patterns and very common ways of dealing with this. These are a few other places where you can go. A user toolbox is a very simple way of creating a complex layout for tools without having to use C++. Custom buttons and menus are also a staple. I didn't cover them because it's something I use. It's something I see a lot in real projects. So I wanted to prioritize things that are a bit less common. Editor modes and scriptable tools are a great continuation from scripted actions, and something I haven't got around, but I really want an excuse to work on it. It is extending insights and see what other tools you can create from there. But yeah, my advice is to spend time looking at the code that is already in there. If there's an area that you like, it's very easy to find where that widget is being created for, and yeah, like using the engine as a reference point is the best way to learn and to discover things that might not even be documented. These are some of the classes that I think you can have a look if you want to see how the engine is handling some of this. And then these are a few links where we can see some examples of scripted actions that are way more sophisticated than what we saw here. They use the old system, so they just change how supported classes work, but otherwise they should work just the same. Then Quadsolar has a very good breakdown of component visualizers and some of the features we couldn't cover here. And finally, there's a very good tutorial on how to create a custom editor, and it was the reference point that I use for the custom viewport. Everything there is 2D, but the framework is the same. And that is everything from me. If you follow the link or use the QR code, the presentation is already there, and the project will follow in a few days. And yeah, feel free to reach out. Also, in this same room, my colleague Jake is presenting Optimizing the Game thread tomorrow, so don't miss it. And thank you.